Welcome back, Honors Algebra 2 students. Mrs. Felon, we are going to do kind of the second part of our graphing rationals investigation. So this is the part that's going to talk about kind of polynomial division. And I'm on that same document that we were on before with the example, with the t of x example, x squared over x minus 1. We're going to kind of finish this off by adding in what we're going to call some other asymptotes. So we've already talked about vertical asymptotes and we talked about x-intercepts. So vertical asymptotes is when the denominator is set equal to 0. So that's the part of the function that's undefined. And we know that the graph approaches the asymptote from both sides. So notice how the side, on the left side, it kind of goes down. On the right side, it kind of goes up. So the function goes up or goes towards infinity on the right side, towards negative infinity on the left side. There's also, by finding the x-intercepts, it gives you a good indication of kind of where the graph is located. It gives you another point of reference, for example. So like here, we have 0, 0. So that allowed us to kind of use that as a guidance to know that, okay, well, our function is somewhere down here. So if we picked like -1, we knew that our function was down here, opposed to like up here in quadrant 2. Polynomial division, what we're going to do is we're going to kind of bring back this whole idea of long division. I know you're probably excited about that. And we're going to talk about how that's going to relate to our other asymptotes. So our other asymptotes are going to kind of be labeled as end behavior asymptotes. And so what that means, an end behavior asymptote is basically what happens to the graph as it approaches infinity and negative infinity. So for example, if we have a horizontal asymptote, like which is a line that goes straight across, as we go towards infinity, what happens to our graph? Does it approach 2, like a horizontal line of y equals 2? Does it approach the horizontal line of y equals 0? Or there are occasions, and especially in this one, you're going to see that it doesn't approach a horizontal line, it approaches an other asymptote. So a slant asymptote, a quadratic asymptote. You can have any kind of asymptote out there. So we've really only kind of looked at vertical asymptotes, whether they're vertical lines or whether they're horizontal lines, but linear asymptotes is what I was trying to get at. And so now we're going to kind of introduce this concept of the fact that an asymptote can be a polynomial. Like I could have a cubic asymptote or a quadratic, a parabola asymptote. Now those aren't as common, and so what you're mostly going to see are going to be vertical lines, horizontal lines, and linear lines. And so a lot of times you'll refer to like the linear equation asymptote, so like an asymptote that's just like a normal linear equation. We refer to those as slant asymptotes. So if you hear me say that or other people say that, that's what they're referring to. All right, so to figure out what your end behavior asymptotes are. So an end behavior asymptote is either, so it's not both, but it's either a horizontal asymptote or what we call an other asymptote. So the asymptotes could be literally anything else. Could be linear, could be quadratic, could be cubic, quartic, whatever. So there's two categories. It's either horizontal or other. So to determine, we do polynomial division. So let's take our t of x equation. So we have x squared over x minus 1. So to figure out this end behavior asymptote, we take our numerator divided by our denominator. Now, I remember long division, right? So we talked about long division, I don't know, back in unit 4, whatever it was. And so what we're getting at here is we're going to use that same concept, but we are going to, we're not going to do as much, okay? So it's not going to be as elaborate as, finding remainders and all that kind of good stuff that we did back in the day. So you're really kind of just looking at some basic, basic division. So let's go ahead and refresh our memory as to how to go ahead and do polynomial division. So if you remember, you take your first term with your first term and you say, okay, what do I multiply x by to get to x squared? And the answer is x. And so then you take whatever you have up here, which in this case is x, and you multiply by the entire, like in this case, x minus 1. So you're multiplying by the entire divisor. So I get, this would be x squared minus x. So obviously there's no term here, so I'm just going to put a plus, a 0 to kind of as a placeholder. And then if you remember the way I taught it in class is I taught you, rather than say, subtract this, I taught you to add the opposite sign. So we change all the signs. So I'm going to change this to a negative and that to a positive. So these should cancel out and I'm left with x. You want to keep going with your division until you get to a remainder. I don't care what the remainder is, but just until you get to the remainder. So like x can go into x positive 1 time. So I can multiply by positive 1. So if I multiply this by, if I multiply x minus 1 by positive 1, I x minus 1, put put my placeholder in there, change my signs, and I'm running out of room here, but that's okay, and I get 1. Here, this is going to be my remainder because x cannot go into 1. So again, I don't really care what the remainder is. What I know now, this is my asymptote. So whatever I get, my answer to my polynomial division is your asymptote. And it's going to be your other asymptote. Your end behavior asymptote is always y equals, whereas obviously your vertical asymptote was x equals. So this is y equals x plus 1. This is a linear equation. So if we were to classify it as either a horizontal asymptote or an other asymptote, this would definitely be in the other category because it's a linear equation. All right, so how that looks, we're going to go back up to our graph, and this will hopefully make a little bit of sense. So if we're going to graph y equals x plus 1, let's start with our y-intercept of 1, and our slope up 1 over 1, up 1 over 1, up 1 over 1, and then down 1 over 1, down 1 over 1. All right, so what you will notice is once you get kind of a few points on here, if I graph the asymptote y equals x minus or x plus 1, that's what it looks like. So do you see how my graph approached my asymptote? Like, so kind of above this, see how it's kind of approaching that and approaching this one? That's on purpose. Because there's this asymptote here, our graphs approach it. And so your end behavior asymptotes kind of just round out kind of what your graph looks like. So we find, again, as a refresher, we find our end behavior asymptotes by doing your polynomial division. Whatever you get as your answer is going to be your either your horizontal asymptote or your other asymptote. How you would get a horizontal asymptote, in case you're curious, let's say I had something like, I don't know, I had the equation 5x over x minus 1, okay? Let's say I had this, and I wanted to do polynomial division to figure out the asymptote. So I did x minus, I taking 5x dividing by, right? So you say to yourself, x goes into 5x 5 times. So you get 5x minus 5, change your signs, and that's my remainder. So see how I just have a number up here? That would mean that my asymptote is y equals 5. Well, y equals 5 is a horizontal line. So it's different. There's no variable in here, right? So that's how you would get a horizontal asymptote, is when you do your division, if you get a number up here, then that's going to be a horizontal line. And so you would draw that as a straight line kind of on your graph horizontally. Let's round this out by talking about, so we've done, again, you can have one or the other horizontal asymptote. We have already sketched it on our graph. Let's do our range. So your range is kind of set up the same way as your domain, right? So it's all real numbers. And then you really have to look at your graph. And we're going to do a little bit of summary on this, but I'm going to have you guys kind of play around with this a little bit to see if you can figure out some of your, some of the more specifics of how to figure out the range. So on this one, what you're going to want to do is this is one type of rational function, and you'll see this kind of this look of a rational function. It's pretty common, but it's not, like I said, there's not like a game plan like all rational functions look like this. So anyway, this point, what you want to know is you want to figure out this point here, which is that minimum, and you want to figure out this maximum. Well, this minimum is the point 2, 4. And I know that because of this, my point that I did here. And you can also verify it on your graph, and I'll show you how with like, well, we've done that before in the past, like doing the minimum or maximum feature on if you hit second trace. This point here is the point 0, 0. So if you're looking at your range, the only part of your graph that really doesn't exist is part in the middle. So how to write this range? Remember, you're thinking about y values. You want y to be greater than or equal to 4, because remember, this is the y value of 4, but you want also y to be less than or equal to 0. So you would write it as an or inequality. So you want you want your y values to be basically greater than or equal to 4 or less than or equal to 0. I use the equals to sign because we're talking about a point here. It can equal 4 and it can equal 0. Because we're not talking about an asymptote here, we're talking about an actual point. And so you could write it as kind of where the graph doesn't exist, kind of like how we did with the vertical asymptote, like x doesn't equal 1. You could say x doesn't equal the numbers that are in this range. I always find it easier to write kind of where it does exist for a range. But that's basically all you're doing for kind of to get you guys ready to do that second part of your graphing rational functions. So once you're done in class, once you're done with part 1, so part 1 was doing, finding the x-intercepts, finding the vertical asymptotes, finding the domain in set notation, and then matching all the graphs. What I would like you to do now is to kind of go back when we'll have class time to do this, but to complete the polynomial division for all of your 8 functions. And that way you can determine the horizontal or other asymptote. So we call that our end behavior asymptote. I'm just going to write that in here. And then you're going to compare the horizontal asymptotes to the graph, like basically just make sure it matches. So when you look at your graph that you picked for whatever function, make sure the end behavior asymptote matches. And then you're going to determine the range. And on your paper, I don't have it on mine, the last thing I would like you to do is draw in your vertical asymptotes or your end behavior asymptote. So we'll just say draw in end behavior asymptotes. So what that means is on all of your graphs, you're going to do what I just did here. And I did like the dashed line here to represent that end behavior asymptote. That's what you're going to do. You're going to add in your vertical asymptote and your end behavior asymptote as dashed lines. And that'll give you a good indication if you had the right graph in the right spot. And that way, if you need to make adjustments, you can. All right, that's it for now. I'm going to do one last video on graphing that's going to kind of cover the little bit of a summary and 7.2, which is out of your book. So kind of just maybe hitting the highlights of what they did in 7.2, which is a little bit different than what we did in this investigation, but just kind of walk you through that. And then we're going to do something called limits. And so if you'll notice in your packet here, you will notice, so after you get through all the graphing, so we're going to do this summary page together in class. This is one of the things that we're going to be doing as a group. And we'll kind of summarize that as a whole group. And my goal is to also kind of do this summary together as a whole group. So there won't be a video on this, but we'll do that together in class. And then I'm going to do on the 7.2 video, I'm going to end it with this page here, which is our limits. And so I'm going to kind of briefly discuss what a limit is and kind of an introduction to it. And it's kind of a bonus activity here. It's not something you're going to find in your Big Ideas textbook. But I think as honor students, I'd like you to at least hear the word and be comfortable with limits. We've talked about limit notation in the past. And so I just kind of want to extend your thinking on that as you get ready for honors pre-calc or pre-calc next year. All right, that's it now. If you have any questions, bring them to class. Bye, guys.